Greetings. Here we have another interesting question from Antennas and Propagation asked in GATE ECE 2002 for 2 marks. A person with a receiver is 5 km away from the transmitter antenna. What is the distance that person must move further to detect a 3 dB decrease in signal strength? You have 4 options. I hope you got this question. So you can pause this video and you can try it out. Otherwise, you can just follow me. See, for example, you have a transmitter antenna. Say I have some transmitter antenna. This is say my transmitter antenna. And from transmitter antenna, there is a person with a receiver. Okay, with a receiver, say there is a person with a receiver antenna, and this fellow is 5 km from the transmitter antenna. Okay, the distance between say this is r equal to 5 km. Okay, r equal to 5 km, say from here to here. Now what is the distance that person must move further to detect a 3 dB decrease in signal strength? If a person, whoever is standing here, if he is trying to move towards transmitter, he could not find any decrease in signal strength, right? So this fellow should move farther from this point, say towards right. He could move this way or this way. For now we will take some movement along straight line. So therefore let's say this fellow is moving from here to here. Okay, now really we don't know how far he has to move so that he could detect a 3 dB decrease in signal strength. Okay, let's stop somewhere like this. Let's say this person stopped here. Okay, this person stopped here. Now he is just resting his hands on his waist and thinking what to do, whether or not he detected a 3 dB decrease in signal strength. Alright, so now okay, as we have couple of distances, let's designate this one as R1, and now from here to here, say let's say from here to here we will designate as R2. Assuming that he is somewhere here and now he is trying to identify whether or not he is under this condition, okay, to detect a 3 dB decrease in signal strength. Alright, now we can understand this way. Electric field strength, the electric field strength at this point, let me take another color. Okay, so give me 2 seconds. Now say the field strength, okay, let me write down here, field strength this is say, let me label this point as some x1 point and say this point as some x2 point. Say field strength at x1 means here. Okay, so field strength at x1 is let us assume as some E1. Okay, now field strength, now this is very obvious. So field strength at x2 is equal to what? Assume that at this, so this is x2, okay, this is x2. Field strength at x2, by the time he is here, he should be able to detect a 3 dB decrease in signal strength. So therefore 1 by root 2 of E1. Yes or not? 3 dB decrease, that means 1 by root 2 of maximum value. Here we have E1. Here we have signal strength as E1, field strength. Now here we have field strength as say E1 over square root of 2. Principal square root of 2. Alright, now anyways E1 generally this is say we are in the far field region, so this point is in the far field. Assume this point is also in the far field, obvious, right? This point is in the far field, this point must be also in the far field. Say this distance 5 km and more than 5 km, whatever, they satisfy Fraunhofer region or in the far field region. Okay, so E1, say this E1 is obviously proportional to, in the far field, e power minus jkr divided by r. Some radial distance is this r. Okay, now we don't require this quantity for now, so because we have r1 r2 stuff here, so we will modify like this: E1 proportional to, say, 1 over r1. This r modified to this r1 because we have r1 distance from transmitter antenna at point x1. Now similarly E2, okay, say E1 by root 2 is equal to E2. See, this E2 is also proportional to e power minus jkr2 by r2. We don't require that e power minus jkr2, so therefore this is also proportional to 1 over r2. All right, now anyways, now we need to find this r2. So we need to find this fellow r2. So now what to be done? Now if I take ratio between these two quantities, E1 over E2, if I take this E1 over E2, we would get R2 over R1. So from this, R2 equal to what? E1 over E2 multiplied by R1. Now E1 is, say this E1 is E1. Now E2, this is, say, this quantity is E2. Okay, this quantity is E2. So E2 is equal to 1 by root 2 square root of E1. So this root 2 will go up. So these two are out. So now what do we have? So we have, okay, into R1. So we have finally R2 is equal to square root of 2 multiplied by R1. Alright, now square root of 2 is some 1.1415 so on, multiplied by R1. R1 is equal to what? 5 kilometer. Okay, 5 kilometer means, say, 5000 meters. So root 2 multiplied by 5000 meters, and this quantity is equal to 7.07 kilometers. Okay, so 7.07 kilometers. That means from the transmitter antenna, if he is at a distance of 7.07 kilometer, he will definitely detect a 3 dB decrease in signal strength relatively from this position x1. Otherwise what would we say? We could say like this, okay, say 5 kilometer plus some x, this is some x, okay, is equal to this R2 equal to, we obtained 7.07 kilometer. Then x equal to what? X equal to the beautiful 2070. Okay, so you will get x equal to 2070 meters. You can put it down in terms of meters. 5000 meters equal to 7.07 multiplied by 1000, so you would get 7070. So 7070 minus 5000 is 2070 meters. Okay, that means from this position, from this point x1, if he moves 2070 meters, he can definitely detect a 3 dB decrease in signal strength. Okay, see, we have used brilliant electric field strength quantity in this problem to deduce things out. Okay, so there is a little bit a concept in this, so please, you have to give emphasis for this kind of stuff. So in the far field region, so electric field strength is proportional to this stuff. So as of now, we don't require this complex exponential quantities like e power minus jkr because directly we have r1 r2 here. So from, see, just by looking at this, we will get the idea. We can omit this quantity and just we can take E1 proportional to 1 over r1, E2 proportional to 1 over r2. Now definitely we can do it, right? Because already we have E1 here as E1, E2 as E1 over root 2. So So that means we have quantities in the form of E1 here. So therefore if I take ratio, I can cancel out E1s, and then I have something in the form of R along with this constant. And this idea we should get in no time, or at least we should think about this for at least 1 minute or two if possible. This is 2 marks question, right? You can take maximum 60 to 70 seconds to solve this. So please do practice as many problems as possible so you can do miracles. Okay, so please do watch things until end, and please do exercise various questions. And in our antenna lecture series, we will try to cover almost all varieties of antenna problems. Okay, so please subscribe. So please share your thoughts in the comment section below. Okay, so for now, bye.